Welcome everybody. Thank you for taking your time. I'll give you half an hour of my world, which is locked in comms rooms and playing with routers and switches and firewalls and that kind of thing. So it's 23, 24 years ago, I think, that the first LGfL tender came out from Brian Durrant and Co. I was the CTO of Equinox Converged Solutions at the time, and very fortunate really, because that timing was all about the emergence of virtualization of networking. So there was quite a lot of networking tech at the time, which is building, that kind of standard grade network. We'd have a bunch of switches and some routers, and you'd have a wide area network of, a frame relay X25, and then you started getting LAN extension stuff. So when the tender came out for 2,300 schools, I think it was quite challenging for applying that traditional technical model to 33 separate LEAs, all obviously with their own requirements for intra-school routing. So I'd like to take sort of credit for it, but of course I can't. There were some very clever people writing RFCs, which are sort of requests for comment documents that come out from the IETF. So basically, we hit the sweet spot of 802.1q VLANs, you'll see. We got virtual firewalling from NetScreen, and really the big one was the RFC 2547, which you may know now as MPLS VPNs. So we had the ability to, through label distribution protocol and so on, the ability to create virtual overlays onto physical infrastructure, which enabled us to build one. Basically says excavating London. It actually was. We were literally digging up half of London at any given time just to lay dark fibre. We put an order for 2,000 LAN extension services on BT. Of course, I think the market for digger drivers and that kind of excavation went through the roof, and we spent quite a long time challenged by the fact that people like BT and others just literally couldn't deliver. We were asking them to do so much in such a short period of time that, we ended up having to fall back a little bit on the ADSL type stuff. But in reality, that there, in a nutshell, is really how the LGfL network came about. And I'm emotionally quite inept, really, but it's quite warming inside to me to see all of this and to see how this literally is a result of what we did all of those years ago. And the legacy and the way that it's been really taken on board and developed through the partners, through VMO2 and through Adept, and where we are now is, this kind of huge scale of network, 3,500 connections, all connected, the stability, consistent performance. Those availability figures are not just plucked out of the air. Our colleague Paul Smith is the one that collates that information on a regular basis. And yes, it is for nearly 5 nines. It's 4 nines of stability and availability. We have advanced telco and core monitoring with our partners, again VMO2 and Adept. And the technology has moved on. In the early days, we were again lucky because companies like Juniper were developing their BGP code. They were developing their BGP code to be extensible with the MPLS VPNs, RFC 2547. It's moved on since then. MPLS has now become the standard. And the Pledge 2020 program recently brought all of those private connections onto VMO2's national IPVPN, which, is MPLS still. The Cisco deployment now, I think somebody mentioned earlier about how one of the ransomware attacks was stopped, and the ability to push config changes out to manage config. This is, going back again all of those years, I could only have dreamt of this kind of longevity. Nobody builds a network. The original contract was for 5 years, and we're still here, and it's just become, almost self-fulfilling. It's fantastic. Recent DDoS response, I don't need to go into that because you'll have heard from people earlier that with our partner Janet and their Arbor DDoS system, we're able to intercept and control a huge DDoS attack. Again, partners all coming together to make sure that was minimized. So as a techie, it's very important to have numbers. 200 gig core, we have 400 gig VMO2 connections out to their IPVPN. We have 200 gigs worth of Janet internet. So these are numbers that basically dwarf the original design. You know, we were talking about 10 meg circuits to schools, and then we're talking about 2 meg ADSL. So the scale and the adoption of new tech has been obviously consistent. So some of the interesting stuff. Talking about scale, constant upgrades, and it's all John's fault. Yes, you can have some free bandwidth. Yes, you can do whatever you like with our network, and you can watch 10 football games at the same time if you wish to. So at some point that has to translate into infrastructure scaling, and that, as it says, is ingress. So your last mile school connection, the egress Janet, and through other DIA connections. And from my perspective, possibly the most important thing is the core service delivery. Again, somebody's mentioned earlier about the web screen NetSweeper upgrade. That is a system, I think it's the largest of its kind, certainly in the UK, which will deliver up to 160 gigs worth of HTTPS decryption as load balanced across 2 data centers. LGfL and ADEPT work very closely on that design, and that is now deployed and waiting for the early adopters, if you like. I've put NAT up there. Elephant in the room, by the way, EITR. This is a TLA, basically. It's a 3 or 4 letter abbreviation. NAT, network address translation, is something that we've become kind of used to. I don't think there's any RFC 1918 to internet connection that doesn't use NAT. Maybe some universities somewhere that were given massive blocks of Class A IP addresses in the early days are still sitting there with publicly addressable machines. But in reality, we all sit behind firewalls, and it's become a de facto security, hasn't it, to have a firewall and just have NAT running on it so nothing can get in and all that kind of. But in reality, that has become a challenge now, and I'll go on to that a little bit later. MPLS, multi-protocol label switching, predictable, robust. It's still there. You know, it was proof that the original designers, and I've met a couple of them, they're just very inspiring individuals in terms of how they have developed the RFC roadmap to enable all the stuff that we're doing. Because without those guys writing the standards, we simply wouldn't have moved on. It's still fundamental because it's deployed at such a vast scale. The IPVPN VMO2 network is huge, and it's testament to that original design that it's still able to do what it needs to, and more. It's developed a lot more since RFC 2547. The comment about moving to underlay, I'll come on to that a bit later, probably in the wrong place, but it's about MPLS. We talk a lot about untrusted models. We talk about, you know, can we use the internet to deliver, you know, our sort of zero trust networking and internet everywhere, untrust everywhere. And MPLS will still play an absolute part in that because it will just be an underlay VRF. It'll do exactly the same thing. We'll just allow people to access the internet directly through the underlay. And again, I'll come on to that a little bit later. And where next with MPLS? Well, this time next year, we'll probably have exactly the same question, and probably the year after, because I don't think it's really going to go anywhere for quite a long time. Those telcos, the big guys, VMO2, etc., have spent a lot of money on this for stability, for scale, and they're not just going to rip that out and put secure vector routing in or put SRv6 or whatever there. It's still fundamental. So we're working. It does constrain us slightly, but it's going to be there for quite some time. There are options. But I don't see any of the large guys doing anything about that at the moment because of that investment in tech. CPE resilience and multi-gig. Another great Mr. Jackson promise, which we all love to work out how we're going to do it. So resilience, I think, well, clearly it's a DFE guideline now. Each site should have 2 connections, should have a resilient connection, which challenges commercially, I think, more than technically. It's technically quite straightforward to add resilience to an existing circuit. The challenge there really is whether you want to make that resilience an active setup or whether you want to have it an active passive setup, because active passive is technically more achievable. Again, I'll come on to that a little bit more. What else have I said? Oh, well, I've already said that. Passive or active bandwidth. Commercially, if you're going to have a couple of 1 gig circuits and you've got a 1 gig circuit sitting there doing nothing, doesn't make a great deal of sense. You might get a little bit from a telco, you might get it reduced in price slightly because they're not using it, so they can plan their core bandwidth a bit easier. But in reality, if you've got a connection, you really want to be load sharing across it at least. Safeguarding versus privacy. I had a chat with, I'm not sure if they're in there, Mark Bentley and David Young, about what can I say about safeguarding, because it's the most important thing. The whole network design is built around the ability to safeguard at scale. This isn't just chucking an XYZ or Smoothwall or whatever box on a site and hoping it'll do. This is, as I said earlier, 160 gigs worth of filtering. There are many other aspects to the technical solution that underpin the safeguarding. The point I'm making there in reality is that I'm a layer 1 to 4 man. I don't really go above that. I can't reach. It's quite easy to stick down to layer 1 to 4. So the layer 3 to 4 stuff is about, obviously, the network layer, IP addressing, layer 4 being the ports, access services and so on. And the impact that we can make infrastructure-wise is decreasing, because the advances in Google and such like are making to browser technology and encrypted hellos and that kind of stuff mean that there's not much from an infrastructure perspective that we can really do about that. So we obviously work very closely with Gareth and Mark's team to make sure that we have that kind of seamless safeguarding approach. Client visibility. So at the moment, obviously, we have a network where, from a safeguarding perspective, you can, if there's a bad actor has done something within the school and it's reported to the police, that website out on the internet can actually identify which school that attack came from, and that's through obviously having every school having its own NAT egress. There's some challenges there. Without trying to get too technical, but I suppose I can because this is a technical presentation. The URL filtering, the upgrade has been predominantly about maintaining safeguarding. So because we need to do HTTPS decryption now, I think you'll all be pleased that that's coming along. That's been a real challenge at scale because it puts a far greater load on basically every single piece of equipment in the chain. What it does also is it introduces another layer. So your client will have a connection to the proxy will decrypt it if you want it to, and then another connection out to the internet. So you're kind of breaking that natural chain of CPA out to the internet. So what normally happens in proxy environments is the proxy will have its own source address. So if that's the source address that the website sees, then you've lost that safeguarding chain because you cannot identify where it came from because all you've got is a proxy, which could have 20, 50, 100,000 sessions. So the NetSweeper system and the use of Altion load balancers have allowed us to overcome that, because what NetSweeper does, it works in a transparent proxy mode. So effectively it spoofs the address. So northbound of the proxy to the internet, what you get is the address of the original school. So you can still recognize that school out to the internet while maintaining the 443 decryption and so on. So that's been a real challenge, and that's been a testament, I think, to LGfL's development skills and working with Adept in particular to deliver that platform within the existing infrastructure. I'll come on to that in a bit more about IPv6. I just want to get the IPv6 out there in case anybody is so scared that they have to leave the room. So technology, important to us, really. Some of you may know that we've been using SD-WAN. If anybody's familiar with what that is, it's an abstraction. Networking typically has a forwarding plane and a control plane in the device. They're typically embedded. Historically, they've been configured locally. You might have some remote management of them and some visibility tools, but in reality, the control plane is the bit that really slows down performance of devices. So you try to abstract it. So the forwarding plane is the bit that moves the bits from one side to the other as fast as it can, and the control plane is the bit that sets up the firewall policies or the routing or the whatever. So SDN's software-defined networking effectively is that abstraction. It's taking the control plane away from the forwarding device and giving you control of the configuration and management of the infrastructure remotely. And SD-WAN is basically a subset of that. So we're able now to have edge devices that forward at speed. However, the configuration management and the actual configuration in terms of what's happening per millisecond is able to be visualized and controlled from the center. So we've had some early deployments of SD-WAN. It has a number of tick box requirements, I call them, because anybody's got a tender, you've got to have SD-WAN on it. Why have you got to have SD-WAN? Well, you've just got to have SD-WAN, haven't you? Because somebody said so. In reality, our approach clearly is about solving problems more than it is about tick box requirements. What it does do is it solves the active-active bandwidth problem, because SD-WAN is designed for every connection to be performance monitored, so there's an SLA applied to every circuit, and it enables either session-based or packet-based load sharing, depending on the vendor. So we've done a lot of work. We've explored a number of vendors on SD-WAN, people like the Viptela thing. We've been through the Versa thing with VMO2. Great bit of tech. We're working predominantly at the moment with Fortinet. Some of you will have seen the little Fortinet boxes, and they are vastly reduced in size compared to the existing deployment. So in terms of standing routers up on the edge next to an Atlas and putting a firewall somewhere on the floor, hopefully we're going to be able to move away from that. Have a single CPE that will do everything. SD-WAN, I think most people just assume that it's an untrusted only technology. So you will use the internet, and this is what we do at the moment with 5G and with Skynet. It just makes me giggle a bit. But, next year there'll be a T2000 here next year. So, but the problem is with the internet, and it's massively improved, by the way. We're not talking about the internet of 15 years ago, or maybe even 10 years ago. That the internet now has become the de facto underlay to everything. Everybody's spoken to a number of councils, a number of MATs, where we're just going to go untrust only. Great idea. However, one of the fundamental pieces of LGfL's deliverable has been its SLA, and the internet. There's a couple of companies out there, Ariake, Kato, a few others, who'll build you a lovely SASE ring around your data centers, provide that zero-touch stuff, but what they won't do, they'll give you a CPE as well, but they won't give you the connection in the middle. So basically, you don't get an SLA. So there's another layer of companies such as Expo and a few others who will do that for you. It's very expensive, and they will provide you an SLA. So we've got to be really careful about the SLA side of things. I would probably state that our SD-WAN as a BAU will be a fixed layer 2 circuit with additional internet-based load balancing, because then we've got the predictability of offering the same SLA that we do now, which is very important. Is Fortinet SD-WAN true SDN? No. Simple question. It enables you to configure the box on the box. It's not quite the same, but going back to the tick box requirements, it does allow us to do a lot of the stuff that we need to do. It's very cost effective. We're just taking advantage of industry changes and trying to adapt them, bring them into the existing core network. Again, a lot of work we do with Adeptis to understand how we move from, basically it's just that technology migration. How do we manage it? How do we protect the risk? Another big thing, clearly, adopting cloud technology, DCI data center interconnect, removing 802.1q. So not stretching VLANs between data centers. It's always been the standard way of doing it because there wasn't really any other way of doing it until the big guys created the cloud, astonishing. The growth of hyperscale, the growth of technology to support mobile workloads, to give you the ability to move your workloads into the cloud. It's quite astonishing the speed at which that's actually happened. And the reason it's happened predominantly is because of layer 2 over layer 3 technologies, VXLAN, virtual extensible LAN, things like eVPN control plane. I'll come on to a little bit more detail in a minute. Core routing and bridging, again, is the aggregation of layer 2 and layer 3 tech, making sure that it's not one or the other, but they're able to deliver both. And the DC mobility and cloud integration is, for me, in terms of the evolution of LGfL network, it's very important that we certainly acknowledge that cloud delivery, not only as an end game, it's very important for LGfL to also deliver those technologies in its core network to enable us to bring you to the cloud. 10 minutes. Wow. IPv6. Yep, I'm taking no arguments on this one. It's going to happen. How it happens is going to be a process, clearly, of evolution. What we are doing is fixing the service scale problem. So at the moment, we have inside London, outside London. We recreate, we have duplicate IP ranges. That cannot prevail. We have to have an IPv6 where every single client workstation in a school is uniquely visible to the internet, because you don't have NAT, you don't have any of those problems. It flattens it out completely. It means we can build service scale without worrying about a separate instance for inside, a separate instance for outside, and whoever else may come along with their own IP addressing. It's kind of getting ready time for IPv. There's a lot of people that are worried about how to deal with it in schools. What do we have to do? Well, we can start talking about that. It's a process that we'll all have to go through. but it gives you that the ultimate safeguarding. It wasn't just the school that had a bad actor, it was that IP address that had the bad actor. We know exactly when it happened, we know exactly who it was, and that's what IPv6 will give us. So LGfL has really moved from a traditional model, go right back to the start, as being an aggregator of other people's services. It's worked exceptionally well. Clearly, VMO2 and Adept have been part of that stability going forward. But LGfL really now wants to become a peer in terms of design and direction. Hence the sort of web screen upgrade and what we've done. A few examples here. So we do our own service and solution design, and provider abstraction is basically about us not looking at what providers have. It's about looking what do we want to do, where do we want to go, and how can we work with our partners, existing and or new, to bring about the necessary change. So a few examples: Public Cloud Connect. I don't think many people have heard of that. That's the ability to connect your site over an IPsec tunnel directly to your cloud instance. So you take an Option 2 VRF into your site and you can connect directly to the cloud. COVID response, Home Protect, working with closely with David Young on this, we're able to spin up the Home Protect client filter-based system for the NetSweep product. The new NetSweeper web screen upgrade, large scale. These are all joint drivers with our partners. SD-WAN POC, that was me working in my kitchen basically and having boxes next to the sink and making things work. And all of a sudden we had some guys, Asif sitting here, who basically said, yeah, we need it because we have a school, we have no connection. And it's become a really good advert for SD-WAN, is the ability to turn up to a site and just turn on LGfL service without digging the ground up and all sorts. So we're doing also the Skynet thing, which is, as far as SD-WAN is concerned, it doesn't really matter what it is. You plug it into anything you want. If it has an internet connection, it will deliver a tunnel over it, and it'll work, and it will load balance. So you can plug it into whatever you want to. Telco resilience, one that is big in LGfL's mind at the moment, is everybody obviously has a connection. Everybody is aware of DFE guidelines. We have to, at some point, deliver that resilient connection. The first iteration, which we're working on with Adept at the moment, is going to be an active-passive setup. So there'll be a BGP failover mechanism. So it'll be somewhere between 2 and 3 minutes failover to the second circuit. But that's in testing when I go to the data center next week and fix it. The Ignite Core, the LGfL network is referred to perhaps as the Ignite Core. There's a lot of work gone on with, obviously with the Cisco guys from Adept, and there's a lot of work going on with Juniper and how we're going to converge those two core networks. John asked me to mention Assemble, and the technical part of Assemble for me was about providing network statistics to the Assemble platform. So I think that individual schools will be able to see their network performance, their individual circuit. So we have embedded in every single router at every school Cisco IP SLA stats, which we're able to scrape off and present them into the Assemble platform. LGfL Labs is me in my kitchen. SD-WAN, IPv6. I really would like to spend more time on IPv6, but I think we're probably going to run out. The cloud, to me the cloud is not really about the cloud as it is. It's about how do we enable every school to get access to the cloud over the LGfL infrastructure. To my mind, the untrust needs to be, you need to be protected from the untrusted environment. So our connections to Janet that we have, also we'll be putting in direct connections with the major cloud providers. With the EVPN VXLAN, we should be able to extend your layer 2 network directly into the cloud over the LGfL network, quite significant for mobile workloads. Again, come and talk to me afterwards if anybody wants to carry on with this. Single pane of glass and visibility tools. So this is really about how do we use new tech such as Prometheus, time series database, things like Grafana, open source platforms to enable us to visualize the network. The thing about Prometheus and Grafana I found out a couple of weeks ago is they're actually the way that Google presents its statistics. So a couple of good technology choices there, I think. Concierge, option 7 on the phone system. Okay, final slide. So SD-WAN, where does it fit? Well, it fits at the moment a proof of concept because we can just plug it in anywhere. But for that service to become BAU, it's not just a technical decision. LGfL, again, has to work with its partners to understand how that's going to be delivered. Zero-touch provisioning is very helpful, so we can send a box to site with some instructions. It can be plugged in, and it kind of phones home and gets this configuration. We've already been through that process. It works really well. Deployment at scale, again, is LGfL and partners working out how to enable that as the new CPE delivery. Physical options, make sure we maintain the SLA. We can plug whatever we like into it in reality, but what we have to do is consider maintaining and, if we can, exceeding the SLA that we deliver at the moment. IPsec SVR probably doesn't really matter to you guys in terms of what it does. IPsec, long live, IPsec is dead, long live IPsec, that kind of stuff. It's de facto for SD-WAN to rely upon IPsec from a lot of vendors, but there's secure vector routing coming out, which is more efficient. It's not a tunnel, it's purely encryption, TLS. I put SASE up there. It's a Gartner term, I don't really like it. Secure access, software edge, it's about perimeter, about delivering cloud. These are the Ariake and Cato type guys. We've looked at that. It probably doesn't fit our model. We've got this hub and spoke network that has proven itself over 20 years to be the right model. I think we'll maintain hub and spoke, so we're not going to go internet breakout from schools, because I genuinely don't believe that's the right way to do it. We should ensure your path to the cloud is through the LGfL network at speed and with SLA. The whole edge thing, people have heard of grey boxes, people have heard of service chaining, putting a firewall, putting a URL filtering in a box and delivering it to customer site. It's all interesting technology, but it doesn't really work with the hub and spoke model. Can we trust the untrusted? I don't think so. Not without sufficient SLA protection, sufficient encryption security, and doing it at scale. IPv6, love it. Get your books out when you get home, bit of bedtime reading. How's it going to work in a school? It basically enables us to reach the next layer of scale. Do we have to have IPv4 to v6 conversion? Probably. Unfortunately, the guys that developed IPv6 probably forgotten that they developed IPv4, and the two are completely incompatible. So there are mechanisms in place that we can use to bridge that. I think the barriers to adoption are more about just being scared of new technology. Everybody understands DHCP, IPv4, and reservations, all that sort of stuff. IPv6 works with multicast. It works totally different than IPv4. Application altnet providers. So we're looking to bring on alternative providers for the resilient connections. Some technical challenges there in terms of that kind of fits outside the existing VMO2 model at the moment. But again, working with partners, we are able to bring that very soon. And I think I'm up, am I? 1 minute remaining. So I doubt there's any questions, but if there are, over to you. So we have 1 minute. But thank you anyway. It's great. I love it. The legacy thing, again, to me is fantastic. The fact that we're still doing this over 20 years later, and it just gets better and better and better. And LGfL, to my mind, is what's been created is the de facto model for educational infrastructure. And it's amazing the amount of people that have tried to do the same, but we're just so far ahead in just about every respect. So on that note, thank you very much.